All right, welcome to session 1 of day 2.2 for the Ceph Developer Summit. We'll be talking about a standard framework for Ceph performance profiling with latency breakdown. I believe our friends from Intel have submitted this blueprint, and Mark Nelson obviously will be weighing in heavily. So I think you guys had some slides. If you want to give us an intro of what you were thinking, and then we can take it from there.
Hello?
Yes, hello.
Okay. So I think we can start now.
Yes, please.
This proposal is mainly about we want to focus on two things. The first one is we want to integrate CostBench to CBT as a performance benchmarking tool. And the other thing is we want to share our findings and experience with current profiling and tracing framework. We have done a lot of performance analysis work on Ceph, and we found that in some words a detailed profiling and tracing framework would be very helpful. So we already have some meeting with Mark. I think from Intel's point of view, in the future we will leverage the CBT as a standard Ceph benchmarking tool. And I think it is good for quick performance testing and doing apple-to-apple performance comparison across different platforms, different Ceph versions. And however, if we took a look on current benchmark or current workload CBT supported, we think it needs an object storage benchmarking tool. So Intel has developed a benchmarking tool called the CostBench, which is the cloud object storage benchmarking tool. It is an open source benchmarking tool, and it is able to measure the performance of different object storage systems, including the Swift, including Ceph RGW, either through RGW or through librettos, and including the Amplidata and AWS. And so the first part of this work, we want to integrate CostBench to CBT. And for the later one is we have trying to do latency breakdown for several months. At the first we added the trace point manually, and I think it is from dumpling version, and it seems like it is very complex and very difficult and time consuming to add those trace points manually. So we are thinking that if we already have a tracing framework like Zentrace or PerfTrace or something like the general tracing framework in Ceph, in this way we can simply leverage that framework to do detailed latency breakdown. It will help the developer to understand the performance bottlenecks better. So this is a simple agenda. We first like to provide an overview of current status and some proposals on how we plan.
The leader has muted your line. To unmute your line, press #6.
One is muted. Go ahead and keep going. That's just a thing we're going to keep hearing periodically. Sorry. That's Blue Jeans.
Are they still there?
Unless maybe it really did mute their line this time.
Yeah. Can you hear us? I think it might be muted.
Yeah, I think they probably clicked it. Yeah, are you back?
There we go. Yep.
Okay. This is the brief introduction of CostBench. So currently, we can see from the bottom pictures that actually CostBench provides a web console to monitoring the test and view the result. From the bottom left picture, we can see how many drivers we have, where is the controller, and for the bottom right picture, it's actually about the performance metrics CostBench can report it, including the read-write, the throughput, the response time, the success ratio, bandwidth, something like that. It also maintains a history history log of all the runs we have been scheduled. So although Cosbins have a command line support, for example, from the upper right box, we can see that there is a script which can submit a configuration file for Cosbench and then kick off the run. Okay, this is a general introduction of Cosbench. And so, considering our goal is to integrate Cosbench to CBT, so we provided a simple approach. We think that this approach would be the most efficient and fast one. We would prefer to depend on the end user to deploy Cosbench themselves, following the Cosbench guideline. That is because that deploy Cosbench is somewhat a complex job. If we leverage CBT to do the deployment work, we need to add in the controller things, the JVM dependencies, the library things, all to CBT. So if we can separate the deployment job, it would be much better. This is like kind of like what FIO is doing. So CBT only needs to give a binary link to over Cosbench, and so in that way, Cosbench can be run by CBT. So Cosbench will be deployed by the end user separately. The next step, we need to add a plugin model to CBT, and we prefer to add the parameters for Cosbench in the YAML file, and then let the module to extract the parameters and save it in a XML file that Cosbench can be used. After that, CBT will invoke Cosbench to do the detailed performance benchmarking work, and then pass the results from Cosbench and generate the final result. Okay. This is the upper right box is actually what we proposed a configuration part for CBT. For example, we can add a Cosbench part in there, and we can define the different settings like the workload name, the authentication part, if there is authentication involved for the RGW, and we can then describe the object size. For example, this is a 512K object test, and we can define the mode, either read, write, or mix, and we can define the ratio. It is 100% read or 100% write, or a mixed mode. After that, we can define the timing part, the ramp up, the ramp downtime, or the runtime. The concurrency is controlled by the worker, the number of workers, and we also have the containers and objects to describe how Cosbench is going to testing the object storage performance. For example, whether it's to do only write data to a specific number of containers or randomly choosing one. With this example configuration, YAML configuration, the plugin module will extract it and generate the Cosbench XML file and translate it into that format. After that, we can use the command line to invoke Cosbench with that configuration file to do the performance testing, and then generate the result. The result is like the bottom picture. It will contain a CSV file named after the workload name. So the other job, the plugin module need to be completed to extract the results from the Cosbench CSV file, and then write to and then integrate into the common CBT result. So this is the general proposal for the detailed implementation.
Sorry,
Mark,
to interrupt for just 1 second. Mark, I don't actually know very much about CBT, but does that model make sense? Where, if I understand correctly, that Cosbench instance will be persistent, CBT will be starting up for each run a fresh Ceph cluster, and then triggering a Cosbench workload. Does that?
Yeah. So we talked about this a little bit before, and I think the trick here is that CostBench already has a very kind of rich framework built into it for kind of how it executes tests. And so the trick here is to figure out how to marry what CBT does, which is basically just like standing up a cluster and then parametrically sweeping through a bunch of different parameters and then tying kind of CostBench into that. I don't think we want them tightly coupled. I think we want to kind of have CBT do its own thing and CostBench do its own thing and try to bridge them.
So what this is basically doing is using CBT to do the cluster startup, and presumably CBT is also doing the parametric sweeps. And then for each combination of parameters, it would generate a CostBench workload, like a different. Is that right?
Yeah. And part of this is figuring out in CostBench how we actually kind of specify that we want specific tests run at specific times. Right now, you kind of give CostBench a configuration file that also could potentially allow CostBench to like sweep through different things. So we kind of have to figure out who does what and how we actually do the submission to CostBench.
So is the goal to get, I guess, is the goal to get CBT to do the parametric sweep, or is the goal to get CostBench to do the sweep?
Yeah.
Or both?
The goal is to like CBT to do the parameter split.
Okay.
What CostBench take is only the XML file.
So in that case, then for each set of specific parameters, it'll submit a job. CostBench will do it right then. CBT will just sit there and wait for it to, or the plugin or whatever would wait for it to finish and pull out the CSV and then dump it into whatever CBT is doing. I don't actually know how CBT stores stuff, but presumably it has something.
So CBT is very dumb. Yeah, CBT is very dumb right now. It just stores the data in a nested directory hierarchy that then basically gets copied back to wherever you're running the script from. I think eventually we need to do something smarter. I was kind of thinking like local SQLite databases that could then be output for each run, and then through tools combine them into much larger databases that you could do like some kind of mining operations on. I think some of the things we have to think about too are in CBT, we would potentially have the ability to sweep through like Ceph parameter spaces. So actually generate multiple Ceph.conf files and recreating the cluster as you're running through tests, which we can't necessarily do in CostBench.
But that's okay, right? For each test, either CBT does or doesn't create a new cluster. But for any given set of parameters, it'll kick CostBench with a particular Ceph.conf and a particular test to run, right? So CostBench doesn't care whether or not CBT has a new cluster or not. That's all CBT's job.
Yeah.
Okay.
And what we kind of have to decide though is, do we want CostBench to sweep through its own set of parameters, or do we want CBT to sweep through those parameters and invoke a single instance of a benchmark in CostBench? I think we might be able to do either. And maybe it would be useful in CostBench to actually allow someone to execute like a specific test so that other tools could maybe make use of it in that way. But we'll have to kind of see what's possible.
The proposal here is to let CBT do all the sweeps. So is that right?
I think so. Unless we're just translating what's in the CBT configuration YAML there into an XML file that would be called once.
I don't think so.
I'm not sure.
Is that right? Is that
okay?
Is that right?
The configuration in the YAML file would be only one section, but it could be generated multiple CostBench XML files. For example, if we define like many test cases, we define multiple runs, then it will generate multiple CostBench XML files, and in that case, the CostBench will be run for several run IDs, like the previous picture I have shown.
Okay.
Does that make sense?
Okay. Mm-hmm. So, yeah, and I think that's probably the way, at least on the CBT side, that would be easiest to do this, because right now, basically, there's kind of like this factory that will create instances of benchmark configurations, almost we'll say. Mm-hmm. So this factory will go through and it will only launch each one with a specific set of parameters. So if we wanted to do it the other way around, we'd actually have to change kind of the way that it works when it's running benchmarks to say, now in fact something else is going to handle this. Launch this particular one with all of these parameters, not just a subset of them.
Okay. Okay. I mean that this all makes sense to me. Sorry, Chindi, for interrupting.
Okay. If no more questions, we will move to the latency breakdown part.
Yep.
Chindi will have to present.
Hi, this is Chindi.
Oh, sorry. Hi.
Okay. I will now talking about the latency breakdown. In the current Ceph code, when we do latency breakdown, it will be slow and time consuming because the trace point in the Ceph code has no semantic, and also we need a homemade script to do the post processing, especially when some trace points are in the OSD level and some are in the file store level. They have different identifier. So this is why we want to do a general tracing framework to make it more general and can visualize it. So here, in the current LTTNG code inside Ceph, as we just talking about that, it's without semantic. In the current blocking patch, which is using the LTTNG and the block zipking to do the latency breakdown, and it follows the Google paper Dapper, so it has the semantic and the trace point format will be more general. Also, it has a united identifier to identify all the tracing from one I/O. You can see from this picture, no matter the trace point is in the OSD level or the file store level, they all have the same trace ID.
Sorry, I have one quick question. Sorry, on the previous slide, when you're saying that the current trace points don't have semantic, are you talking about the ones like the librados and librbd trace points, or are you talking are those ones that you mean?
Just the trace point using a function as trace point, and it has a identified like they will call OID in the librados, and using the other kind of ID in the OSD level, something like that.
I think the problem is there is. Sorry, please go ahead.
I just want to make sure I understand, because I know we added trace points in librados and librbd that basically just mirror the actual function calls, so you can trace who's using the API and what their arguments are. I don't remember actually. I don't think we've added anything on the OSD side that uses LTTNG yet. But I just want to make sure. Yeah. Okay. So you're talking about the RBD and librados ones.
I think for the tracing part, one of the challenge job is we need to have some kind of ID to track the single I/O request entire life cycle.
Yep. Got it. Okay. Sorry, you can keep going.
Okay. In this page, you can see because they're using the united ID to identify the whole I/O request, and also it will using the span ID and parent span ID to level the trace point. So when using the semantic, they only have the timestamp and the key value, two kinds of semantic to describe the trace point. So it will be much simple to do the post processing and to understand these trace points. So when we trace using the blocking patch, we can get the we can print out the results in the zipking web page. It's kind of like this page. And if you click one I/O request, you can see the whole latency breakdown picture here. And because we use the span ID, so the latency is leveled in different levels. So you can see just the OSD level is in the level 2, and the file store is the level 5.
Cool.
And also, when you click the OSD, you can see all the trace points. Okay, so our goal is.
Oh, I was just wondering.
Yeah.
Sorry to interrupt. The web interface for looking at the results. Is that kind of like what's the back end of this? Is it like SQL, or is it like, can you just like read files?
Sorry, I don't understand.
How does the data get into the web interface?
Okay. At first, we need to produce the trace point using the LTTNG. Then it will store in the LTTNG file, and we're using a Python to send this LTTNG trace point to the zip key. Zip key has 3 daemons. One is the collector, and then the query and the web page. So the collector will receive these trace points and store into his database.
I see. Okay.
Okay, then we can just show the latency breakdown from the web page. Oh, is that clear?
Yeah.
I think so.
Yeah. Thank you.
Okay. Then our goal is building a general framework to include most important trace points and using the blocking patch. So our approach would be in these 3 steps. One is to provide a script to deploy LTTNG and ZipKey, because they are 2 different separate modules. And then we need to add more trace points in the Ceph codes to cover other parts, like message part, OSD part, journal part. And the third part is we need to do some modification to the ZipKey to view the latency more better and more clear. And the current gap is the blocking patch is not merged to the Ceph master code yet. But the days ago, Andrew, the author of the blocking patch, is already sent out his version 5. So he said it will be promising to merge in minutes, I guess. So this is a gap. And if the blocking patch merge into the Ceph code, we can cover other messages besides the MOSD OP. Maybe we can do some trace points in the pairing, something like that. And the third gap is when we do the zip key, it only shows one specific I/O latency, but in our test, there will contain like 10,000 of I/O in one round. So we think we need to add a summary page to make it more clear. And the third part
that would be, sorry, for that would be a change to the upstream Zipkin project, which is, that's a proposal to change the Zipkin web interface.
Yeah, I don't think so. That part can be implemented on the Zipkin part.
Yeah.
Currently,
okay.
Zipkin only receives, it needs some post-processing or statistics to calculate the overview for the latency breakdown.
Got it. Okay.
That's the gap. Okay. We mean it needs an overview.
Okay. And that's a Twitter project, right? Yeah. Okay.
Yeah.
Okay. Sorry. Go ahead.
The forces, this is pretty tricky because we can't to link the trace from the client and the primary nodes and the replica nodes, because the server system time delta problem. So we need to think out a way to solve that.
I wonder if there's a script that you could use that would take the two trace points and look at events that are clearly the same, where you're sending a message and receiving a message, and then try to look at a bunch of those and just do a post-processing step that basically adjusts all the timestamps to be sort of the minimum delta between the two. Does that make sense?
But the problem is it's not easy to get time delta by the microseconds. We can maybe get the seconds or one.
Yeah.
It's not against the microseconds.
If you have the client sending like 1,000 requests, and on the server side you see like those same 1,000 requests being received, can't you take the timestamps between all of those and pick a delta that sort of minimizes the difference between the two?
Yeah. Yes, we can try that.
Yeah. Okay. Just an idea. So just on 1 and 2, or 1 especially. So the goal is definitely to get this merged in. Andrew isn't here, unfortunately, but he was blocked because he was seeing crashes when he was running it. There was like some sort of memory corruption that I think he worked with Josh recently and fixed that, but I'm not sure. So if you guys are actually running this patch,
as I know, he ran into the memory corruption problem in the version 3, and I just helped him to figure out what the problem is. So awesome. He moved to the version 5, and I think currently the code is bugless. Okay. Maybe awesome. We need to do something to light the overhead, but it's bugless.
Awesome. Okay. And if the code is merged in, I confess I haven't looked closely at the patch, but if we merge this in and you have block-in is all disabled and everything, is there a cost to having these trace points there, or is it only sort of flow things in when you enable all the trace points?
The zipkin is somewhat offline processing, so I don't think there is a huge performance cost for this.
For the block-in piece though, like adding all these trace points, are they sort of free if it's disabled?
Pardon, can you repeat that?
If all the trace points are added and the trace points are disabled, so you're just running normally in production but not tracing anything, is there a cost?
Yes.
Or is it?
Yes. We use the LTTNG to do the trace points, so you can just disable all the events.
Of course. Okay. Awesome. Okay. So I think probably the way forward is just to get Andrew's patches that he posted to the list, the latest version, in the form of a pull request, and we can merge it into a test branch and run it through the QA suite and make sure it actually doesn't break under all of our stress tests. And if that's okay, then we should be in good shape.
Sure.
Yeah. But sounds great. Okay. Yeah, this is really awesome though. Thank you very much for the help with tracking down the bugs.
Thank you.
So we're actually over on time on this one, Sage. I don't know if you want to push on this one or.
I didn't have any other questions.
I have one question. So is this something related to this off tracker as well? So to get this trace, is there any dependency on the off tracker?
No,
sorry, I can.
He was asking whether this is related to the op tracker, and it's not related at all. So the op tracker is basically like a really simplified version of this that's embedded in the daemon. So you would probably just disable the op tracker and use this instead if you wanted to do this level of profiling. But the op tracker, I think, is more targeted towards like a production system where you want to figure out what the current state of the system is, whereas this is really about, I think, performance analysis, I think. But
yeah, so another question I have regarding this, like crossbench integration. So my understanding is that crossbench will stress this RGW paths, right? So so am I right?
Mm-hmm.
And then so we are planning to actually see the how much degradation per release wise, but the RGW itself is actually very low performant, and if there is any degradation on the say actual cluster side, right, it may not able to detect because anyway it's bottleneck on the upstream, right? So in that case, how actually you will able to figure it out that is there any degradation on the Rados side?
Did you catch that, Chendi? I wasn't quite able to follow.
Sorry, I don't.
So what I'm saying is that if you actually integrate Rados bench, this cost bench with to get this performance degradation release by release, right? So my understanding is that it's from the RGW side. So RGW itself is actually its bottleneck on the upstream level. So if there is degradation on the Rados suit, it's OSD level, right? So it won't be actually able to detect from the cost bench side. So that will help on the RGW side, of course, but will not detect any degradation on the OSD side.
I believe there's a Liberados driver for Cosbench as well. Is that right?
Yeah, there is a Liberados driver for Cosbench, but the problem is it matching the container concept to the level of a pool. So in that case, if you are doing like 100 containers, there will be 100 pools. So there might be some issues.
You can switch that to use namespaces pretty easily.
Maybe. But it also have a RGW plugin. So currently Cosbench can go through the RGW and also can work like Rados bench to use the Liberados driver directly.
Okay. The number of containers that Cosbench tests against is just one of the random parameters that you give it, though, right? You could just as easily say test against one pool.
Yeah.
Okay. But it seems
and
like
presumably we will. Oh, I was just going to say, presumably we'll be running multiple tests, right? We're not just going to be running Cosbench. We'll use Cosbench, we'll use Rados bench, we'll use FIO, we'll use all kinds of other stuff, potentially.
Yeah.
In the case that, so Cosbench itself is all written in Java, is that right? That means it's using the
all written in Java.
DNA wrappers?
Yeah.
Okay. So I would be more concerned that the JNA overhead is not enough to drive the performance that Somnath you're probably looking for. But it would depend on what backend you are using.
Yeah, we're actually using Cosbench to measure Swift RGW and the Liberados performance. I think the Java, the Genius shouldn't be a performance issue because on our internal cluster, we were able to drive the hardware limiter.
Yeah, okay. That sounds good to me.
Yeah, I had one question, or probably a proposal, kids. So does it make sense to add some kind of tracing levels to this rather than having a single level so that we can probably enable parts of the tracing?
Do you mean adding some tracing layers in the tracing framework? Not layers, levels.
Like I can enable level 1, level 2. Level 2 might be a deeper trace, right? Instead of having a flat level of tracing.
In our initial plan, we also want to do this. For example, we only care about the OSD level. Only adding enabling 2 trace points. One is when to enter the OSD part, and after that when to enter the journal or file store part. But that basically depends on how many trace points you enabled in our TTNG. So it's quite simple to implement that, but different people may have different opinion what level they want. We can propose a draft on, for example, we can provide the simplest tracing data what the client part latency is, what the OSD part latency is. That's what we can do.
Okay.
Does that answer your question?
Okay.
Yeah.
Okay.
Could you upload the presentation to the wiki page, at least in PDF version also?
Yeah, sure. We will upload it later.
Great.
Wonderful.
Awesome.
Okay. Thank you very much.
Thanks, guys.